Hello everyone, welcome to Quadrilaterals Part 1. In this session, we will learn about what is a quadrilateral and what are the different types of quadrilateral and their properties. So let us study what is a quadrilateral. As we all know, a quadrilateral is a closed figure formed by four line segments. And based on these sides and angles, we have different types of quadrilaterals. So let us start with the rectangle first. A rectangle is a quadrilateral in which opposite sides are equal. And if we talk about the angles, each angle of a rectangle is equal to 90 degrees. And diagonals. We know that a diagonal is a line segment joining the opposite vertices. And a rectangle has two diagonals. And the diagonals intersect at a point. And let us study about how these diagonals are. The diagonals of a rectangle are bisectors of each other, means AO is equal to OC, BO is equal to OD, and the length of the diagonals AC is equal to BD. So these are the properties of a rectangle. Now let us study about our familiar quadrilateral, a square. A square is a quadrilateral in which all sides are equal and each angle is equal to 90 degrees. And if we talk about the diagonals are the perpendicular bisectors. Bisector means cuts into two equal parts. And in the case of a square, the diagonals are perpendicular bisectors. That means the angle formed between the diagonals is equal to 90 degrees. And the length of the diagonals is also equal. Now let us learn about parallelogram. A parallelogram is a quadrilateral in which opposite sides are equal and parallel, as in the case of a rectangle. But here, each angle is not equal to 90 degrees, as in the case of a rectangle. We can say that opposite angles are equal in the case of a parallelogram. And if we talk about the diagonals are bisectors of each other, but they are not of the same length, as in the case of a rectangle or a square. That means length of AC is not equal to length of BD, but they are the bisectors. So this is about the properties of a parallelogram. Now let us learn about a rhombus. A rhombus is also a quadrilateral similar to the square, but the difference, we will see what is the difference between a square and a rhombus. When we compare a rhombus and a square, one property is similar, that is, the sides are of same length. But we can't say that each angle is 90 degrees as in the case of a square. Here, the opposite angles are equal. And if we talk about the diagonals are the perpendicular bisectors of each other. That means the angle formed at the point of bisector of these diagonals makes an angle of 90 degrees. And you can say that these diagonals divides the figure into 4 congruent triangles. And in our previous sessions, we have learned about the congruency rules and the conditions when can we say that the two triangles are congruent. So based on one of the criteria, we can say that these are 4 congruent triangles in the case of a rhombus. Now let us learn about trapezium. A trapezium is a quadrilateral in which one pair of opposite sides are parallel. Any one pair it can be. So if we see in this diagram, here this and this and it is AB is parallel to CD, and the diagonals are not the bisectors or perpendicular bisectors. We can just say that the diagonals intersect at a point, common point, and we can label it as O. And this is about the trapezium. And another quadrilateral we have is a kite. Kite is a quadrilateral in which angles. If we talk about the angles related to the kite, one pair of opposite angles are equal. And in the case of the diagonals, if we talk, the diagonals are the bisectors. One pair is bisected. That is, here only one diagonal gets bisected perpendicularly. That means the length of this side is equal to the side, but this side and this side of the figure, that is the diagonal, so part of the diagonal is not of same length. So let us have again, let us name the intersecting point of the diagonals as O. That means one diagonal is bisected by the other diagonal perpendicularly. And if we talk about the other diagonal, we cannot say that it is also bisected. It is just cut with the other diagonal. So this is about the properties of a kite. And these are all the different quadrilaterals. And if we know the properties of quadrilaterals better, we can simplify or solve the sums related to the quadrilaterals. So let us just revise once again. A quadrilateral is a closed figure formed by 4 line segments. And the different types of quadrilaterals are rectangle, square, parallelogram, rhombus, trapezium, and kite. And let's learn about the angle sum property of a quadrilateral. In our previous classes, we have learned about the angle sum property of a triangle. We know that in a triangle, the sum of angles, the 3 angles, is equal to 180 degrees. So let's see what is the sum of all angles of a quadrilateral will be. So for this, let us just draw a quadrilateral and name it as ABCD. It can be any quadrilateral we take, this property will be proved. So let us name this quadrilateral as A, B, C, D. Let us take one diagonal. Let AC be the diagonal formed. And now we know that Here the quadrilateral is divided into two triangles. Let's name this as triangle 1 and triangle 2. And we know that sum of angles in triangle 1 is equal to 180 degrees, and sum of all angles in the second triangle is also equal to 180 degrees. So what can we say? We can say that the sum of angles in a quadrilateral is equal to 360 degrees. That is, the angle sum property of a quadrilateral says that the angles add up to 360 degrees. Mathematically, if we want, we have to name the angles and then we can proceed for the proof. So let's see how it goes. I name this as X, Y, Z, E, Q, R. So mathematically, if we want to proceed for the proof, we have to take in triangle 1. So in triangle 1, angle X plus angle Y plus angle Z is equal to 180 degrees. And in triangle 2, angle P plus angle Q plus angle R is also equal to 180 degrees. If I combine this two equations, I get angle X plus angle Y plus angle Z plus angle P plus angle Q plus angle R is equal to 180 plus 180, we get 360 degrees. Now, angle Y plus P makes one angle of a quadrilateral. So this plus this makes one angle, and angle Z plus R. So Z plus R, this and this makes one angle. So let us name it as X plus angle Q does not change. So let's name it as A, B. So that is angle A plus angle B. That is four angles of the quadrilateral will add up to 360 degrees. So this is about the angle sum property of a quadrilateral. Hope you have understood the properties of a quadrilaterals and the angle sum property of a quadrilateral. In the next session, we will try to solve some problems based on these properties. Thank you.